Hi guys, welcome back. Today we'll be solving LeetCode question 1497. Check if the array pairs are divisible by k. So the problem statement says, given an array of integers ARR of even length n and integer k. So we are given an array of even length n and we are given an integer k. So we want to divide the array into exactly n by 2 pairs such that the sum of each pair is divisible by k. So what we have to do is, out of the given array we need to pick up two numbers every single time, and the sum of those two numbers should be divisible by k. If all the numbers are used in making pairs whose sum is divisible by k, we return true, otherwise we return false. So to visualize the question even better, let's come to the interactive array arrangement visualizer that I have created for you guys. So the first step is to input the array and the integer k that we are given. So let's take this example 1 2 3 4 5 6 7 8 9, and we take k equal to 5, right? 1 2 3 4 5 6 7 8 9, and let's take k as 5 and visualize. So this is the array that we are given, right? 1 2 3 4 5 10 6 7 8 9. So we are done 25%, right? This was the first step, to enter your array of integers separated by commas and provide a value of k, then click visualize to start the process. So the next step is to initialize and populate the hash map. So what we'll do here is that we'll create a hash map to store the frequency of remainders when elements are divided by k, and this map will be populated as follows. The key of the map will be the remainder when an element is divided by k, and the value of the map or value of the key will be the count of elements that give this remainder. So what this means to say is, for example, if we have element 1, we will divide the element 1 by k. So 1 percentage 5. What 1 percentage 5 will give us is the remainder. So it will give us 1. So remainder 1. This remainder 1 will be the key to the map. And how many times this remainder 1 will come is the count, which will be the value of the key. So for each element x in the array, we'll calculate the remainder to get the positive. Okay. So this is something we need to be careful about. If we want the remainder of a positive number, we simply can do x percentage k. But what if there is a negative number also? Because in the constraints, element of array can be a negative integer, right? So what if it is a negative integer? We will use this formula, x percentage k plus k and whole percentage k. So what this will give us is the positive remainder. For example, let's take x equal to negative 14. When we'll do negative 14 percentage 5, we get negative 4. Then we add positive k, that is positive 5. So we get 1, and 1 percentage k is 1, and hence we get the positive remainder. The second step will be to increment the count of this remainder in the map. So to code this, let's code this first. We'll create an unordered map first. Let's create an unordered map. Let's name it M, and then we'll traverse through the array. For example, x is the element, and we'll add all the remainders into the map. So let's calculate the remainder as x percentage k plus k and whole percentage k, and let's add that remainder to the map. So map of rem plus plus, this will increase the count of the remainder. The next step is pair checking. So to check the pair condition, so we now check if the elements can be paired to form the sums divisible by k, and we do this using the remainders that we have calculated. So for remainder 0, now what if the element is a multiple of 5, right? What if the element is a multiple of k? So that cannot be that we cannot find a complement to a element whose remainder is 0. So what we'll do is we will traverse through the map pair in M, and we will check if the remainder is 0. So let's calculate the remainder as pair dot first, and let's calculate the count as pair dot second. Well, not calculate, initialize. Now we check if the remainder is 0. So if the remainder is 0, we check if the count is an odd number. So if the count of that remainder whose element whose remainder is 0 is an odd number, we just return false. So if count is an odd number, we return false, because there will always be one single element which we cannot pair it with anyone else. And the else condition will be to calculate the complement. So for non-zero remainders, we'll calculate the complement as k minus remainder, and the count of the complement must match the count of the current remainder. So for example, if the count of remainder 1 is 2, we will check the count of remainder of 4, which is a complement of remainder 1. So to calculate complement, let's initialize complement as k minus of remainder, and let's check if the count of complement is same as the count of remainder. So if complement, so if the count of complement is not equal to the count of the remainder, which we have already initialized as count, then we just return false. And if everything goes well and we reach the end, we just return true. So in this case, everything is green, right? So the final result, we can say the array can be arranged into pairs with sum divisible by 5. What if I change the array? So what if, let's say I input the array as 1, 2, 3, 4, 5, 6. Let's do some negative numbers, -6, -2, -4. Let's take k as something like 4. Let's visualize. Step 2 is to initialize and populate the hash map. Next, so remainder 1 doesn't match with its complement, right? Also, remainder 3 doesn't match with its complement. So there are red conditions, and hence the final result, we can say that the array cannot be arranged into pairs with sum divisible by 4. So let's see if our code works. Yes, it does, and let's submit it to check for the test cases, and it does work. That was it, guys. Thank you.